Hi everyone, welcome to Data Precision with Shino. And what we're doing today is a Google Skills lab titled BigQuery Quick Start using the command line. And this is the Google Cloud Self-Place Lab 071. That's GSP071. So first of all, from the overview, we are now going to look at what we have here. That storing and querying massive datasets can be time consuming and expensive without the right hardware and infrastructure. BigQuery is a serverless, highly scalable cloud data warehouse that solves this problem by enabling super-fast SQL queries using the processing power of Google's infrastructure. Simply move your data into BigQuery and let us handle the hard work. So this is a message from the Google team that let them handle the hard work. You just move your data into BigQuery just by connecting it. Now you can control access to both the project and your data based on your business needs, such as giving others the ability to view or query your data. That is um, identity and access management under the Google Cloud. So you can access BigQuery by using the console, which is here. So here is the documentation in console, and through the web UI or a command line tool using a variety of client libraries such as Java, .NET, or Python. There are also a variety of solution providers that you can use to interact with BigQuery. Now, this lab will show us how to use BigQuery, okay, the Python-based command line for BigQuery. So it's BQ, which is the Python-based command line for BigQuery, to query public data sets and load sample data into BigQuery. So this is what we'll be doing today. We'll query a public data set, we'll create a new data set, we'll load data into a new table and query a custom table. So here are some guides on starting the lab. So we have the access through internet browser, which is recommended we use Chrome browser, which we are in now. There's a timer that shows us how much time we have and how much time we're limited to. And once we want to start, we click the Start Lab button. So once the Start Lab button is clicked, we're going to have another button under that shows somewhere around here the Open Cloud Console button. It will search our time limit to start counting down, and we'll see the temporary credentials underneath. So there should be a screenshot here. So okay, there's a screenshot here. So we know that that's how we will start our lab. Now let's go a bit into the tasks. So the first thing you have to do is to activate your Cloud Shell. So Cloud Shell, you can see from here. So to access Google Cloud products, click the navigation menu or type the service or product name in the search field. So this is our navigation menu right here, or here you can type to get a resource or service. And not far from it, our Cloud Shell button is there, but it's on this image. Now, our Cloud Shell button is the greater than and underscore. So wherever I see it is the terminal logo. So there are some pop-ups that will come up when you activate your Cloud Shell, which you would authorize. And once you're connected, you can indicate and see where or what your project ID is for that session, which we can do here. It's an optional task. So once we put in gcloud authorization list, it will give us something like this on this output. So we can also see our list of projects, that if our project is listed, so you can see gcloud config list, and an output will be core project ID. So we can see documentation for other information. So here's our first task, examining a table. So BigQuery offers a number of sample tables that we can use to run queries against. And in this lab, we'll run queries against the Shakespeare table, which contains an entry for every word in every play. So every play by William Shakespeare. So to examine the schema of the Shakespeare table in the dataset, we run BQ show BigQuery public data samples Shakespeare. So here we're using this to examine the details of the Shakespeare table. So let us start the lab so we can go and activate. So here we have the prompt to let us know we are not a robot. Select all images with cars. So we have six tasks and the seventh is a cleanup. So we're starting our first task once our open console dialog is up and running. So now we're going to open our cloud console. Remember, open it in incognito window. We'll be giving our access to resources on the Google Cloud Console, and we accept. Okay, so once this is fully activated, we'll have this coming up on the command line. Okay, so activate our Cloud Shell. So these are our checkpoints, which would automatically be updated as we move on. So first, let's test out our G-Cloud authorization list. So remember, we authorize it. So so we can see our user account active. Next, we would see our list of projects. So for those who will be using smaller screens, let's change our text size to medium so we can have a better view of it. So you can see the output will look like this, which is what we have here: core, project, and our active configuration. See it here. So next, we want to examine the table. So let's examine the schema for Shakespeare table. We'll run this. So BQ calls BigQuery up. So you can see here the table BigQuery public data sample Shakespeare last. So let's make some customizations here. You can have let's show the scroll bar so we can go. So let's just not using the build scroll bar. So here we can see our clustered fields, last modified, total logical bytes, schema, total rows. total physical bytes, total bytes, labels, expiration, time, and partition. So let's go to the next. Remember, BQ is to invoke the BigQuery command line. Show is the action that the BigQuery command line would take. And then we're listing the name of the public dataset table in BigQuery that we want to see. So here's what ours to look like, the output. Now we'll run the help command to see information about the query command. So once you let's scroll back up. So query command executes a query. Query should be specified on the command line. So I think we need of text size to be larger. Good. So query executes a command. Uh, let's change it back because we need we let's be aligned. So flags for the query, front end command query. So we have front end flags, we have absolute flags. Now, just to see a list of all the commands that BigQuery uses as BQ uses, we should run just BQ help. So initially we ran BQ help and query. So now let's run just BQ help. So BQ help gives us the commands for BQ in an alphabetical order. We have add IAM policy binding. We have cancel. We have CP that copies one table to another. Here's an example. BQCP dataset old tables dataset to new table. Extract performs an extract operation. The usage here you have extract the source table beside the destination URIs. So we use M option to extract a source model. We have the get IAM policy for a resource. Example is BQ BQ get IAM policy for ds.table. BQ get IAM policy. So you can see the usage is get IAM policy in bracket the identifier. So we have the others. So next, let us see how we run a query or tax tree. Now we'll run a query to see how many times the substring raisin appears in Shakespeare's works. That's William Shakespeare's writings. So to run a query, we'll run the command bq query with the SQL statement in quotation. Escape any quotation marks inside the SQL statement with a backslash mark, or use a different quotation mark type than the surrounding marks versus. So run the following BigQuery in Cloud Shell. So we can see how they said BigQuery use legacy SQL false backslash select word some word count as count from BigQuery public data samples Shakespeare, where we want words like raising group by word. So let's go and run this. So here's our results. So we have word and the count. So remember we use praising raising. So we have praising with small letter p. We had raising with capital P, raising with a G, because we have dispraising, we have dispraisingly, we have raisins. So that went well. So in this command, we use legacy SQL false, makes standard SQL the default query syntax. So we can see it as a more like a standard SQL. So remember, legacy SQL from in a couple of months, Legacy SQL, which is an older proprietary SQL dialect for Google BigQuery, designed before the adoption of standard SQL, uses specific syntax like Legacy SQL, table detonators, and has limited functionality compared to the modern ANSI compliant SQL. So Google advises using standard SQL for better performance. So I think Legacy SQL support is just a side support by Google. So I think Google is taking down their support Legacy SQL in 2026. So Google BigQuery service continues to support Legacy SQL, but it has established a strict availability framework to phase it out in favor of the current Google SQL, which is standard SQL. So evaluation period. Google is currently monitoring Legacy SQL users for projects and organizations that do not use Legacy SQL between November 1st, 2025 and June 2026. The dialect will become unavailable. So as I said, it's going to become available in 2026 for most people who don't use it. So back to what we're doing, we have our output. Now, this table demonstrates that although the actual word raising doesn't appear, the letters appear in order in several Shakespeare's works. So let's check our progress. So good. Assessment went well. So if you search for a word that isn't in Shakespeare's works, no results are returned. So let's run the search who's for return and returns no matches. So let's go and see. We want to search for the word user. So we can see that there's no results because this came back blank. So let's check our progress. Now we want to create a new table. Now create our own table. Every table is stored in a dataset. A dataset is a group of resources such as tables and views. We're going to use the BQLS to list any existing datasets in our project. So remember, wherever you see ls in bash is list. So let's see here, ls in bash. So ls is a command used in bash to list the contents of a directory. By default, it displays the names of files and folders in correct working directly in alphabetical order. So you can customize the output by adding various flags. We have -l long format, we have -a all, we have -h human readable, -t time, -r reverse, we have -r recursive. So we have capital R and small letter r. We have -s capital S size and -f indicator. Indicates that a character appends a character to entries to indicate the type. So that said, let us go and use our BQLS. So remember, it's better to type in. So we're saying BQLS and there's no results. That's why we're being brought back to command line since there's no data set in the project yet. So we're going to run BQLS and the BigQuery public data project ID to list the project in that specific directory. So we want to list all projects in the BigQuery public data. So we should have a result like this. The large data, let's list it. So it's trying to read it. So we have the results here. We have it as alphabetical order. So now create a dataset. A dataset can be up to 1024 characters long and consists of A to Z, capital A to Z, small letter, and 0 to 9, and the underscore. But you cannot start with a number or underscore or have spaces. So we use the BQ make command to create a new dataset, name baby names in our project. So when we use the make command, it automatically gives it automatically creates the name, creates a data set. So no, we're not making a direction, I'm making a data set, and it's going to use this as the name, baby names. So you can see here it says baby names successfully created. Data set, our project ID, then baby names successfully created. So we can see it here, data set, project ID, baby name successfully created. So let's check our progress. Now we'll run BQLS to confirm that dataset now appears as part of our project. So let's see. Oh, sorry. Meant to have ls. So we can see baby names, dataset ID exists, just like what we have here. Now we're going to upload the dataset. Before we can build a table, we need to add dataset to our project. The custom data file we use contains approximately 7 megabytes of data about popular baby names. We'll run this command to add the baby name zip file into our project using the URL of data. So this file is gotten from the ssa.gov website. Let's have a look at it. So that's the social security website for the United States government. So they are publicly available resources. So let's so GNU widget is a free non-interactive command line tool used to download files from web servers via HTTPS, HTTP, and file transfer protocols. It excels at retrieving large files, mirroring an entire website, and working in the background even after a user logs off. The WeGet is highly robust and handling slow or unstable network connections by automatically retrying download. So it no matter what, it always gives a handshake to get what it wants. So we've gotten that information about WeGet. So we're getting the WeGet, the website, and the file. So we're going to run that on us. So we can see, just like it said, it keeps trying till it gets what it wants, and it has gotten it, and it told us it has saved it. So let's put ls. So we have the names.zip listed with our readme cloud shell text in our directory. So we can see the name of the added file in our project, which we have done. Now we want to unzip the file. So unzip is a also a command to unzip zipped files. So we have unzip the names of zip file. Remember, it's on the ls directory. It has unzipped it, and then we go ls again, and we can see everything listed within that directory. Now, the bqload command creates or updates a table and loads the data in a single step. We'll use bqload command to load our source file into a new table called names 2010. So the bqload arguments we are running are dataset ID, baby names, table ID, names, source, and schema. So this is what we're going to get. Remember bq load baby names dot this yob 2010 text, which is the source. Name is a string type. Gender is a string type, and count. So let's go run it. So we're saying upload complete, waiting for job, and current status is done. So you can see the same message we have, they also have it. So let's check our progress. So next we're going to run BQLS and baby names to confirm that the table now appears in our dataset. So let us list. So we can see it has given us a schema of our baby names table. So the table ID is name 2010, type is table. So let us go. So you can see it name 2010 and type table. So run the BQ show and dataset table to see the complete schema. So you can see complete schema. We have it displayed here. Here is an undernote. When you load data, BigQuery expects the UTF encoded data. If you have data that is ISO 88589 or Latin, encoding and are having problems with your loaded data, you can tell BigQuery to treat your data as a Latin one explicitly using the E flag. So you can learn more from this link. Now, following task is to run queries. We'll run the following command to return the top 5 most popular girl names, female names. So let's run this. There's other count than 5. So because we have limits as 5, so it gave us where those gender is female and order by count limit 5. So next we're going to run the following command to see the top 5 unusual boy names. Let's see. So we're waiting for the results. So here we can see gender is male and order by count ASC limit 5 as ascending. Here descending, so ascending. So the next thing is that you can see the minimum count is 5 because the source data names with fewer than 5 occurrences. So we can check our progress to know if our task has been completed. Okay, so now what test our understanding? Below are multiple choice questions to reinforce our understanding of the lab concepts. Answer them to the best of our abilities. So we can access BigQuery using what? Can access BigQuery using the command line tool. What's the glib? I've heard of the glib before. That's the GStreamer. Let's see BigQuery REST API. Next is the web UI. least one. I thought so. I said one. Yes, at least one more. Oh, one more correct answer. Okay. Very good. At least one more correct answer. Oh, so we have more than these two. Okay, so BigQuery recipe as the last. Okay, so now which command line tool is used to interact with BigQuery service? Which command line tool is used to interact with BigQuery service? So the command line tool that is used to interact is BQ, which we had used already. So we'll run BQ RM command to remove the baby name dataset from the R flag to delete all tables in the dataset. So it's BigQuery remove all everything has the baby names. Confirm delete command by typing Y. So giving a command prompt. It's going to be yes or no. Remove delete dataset. So Y. So let's see if we removed it. So verified our progress. And thank you for watching the video and see you in the next one.